Hello everyone, I am PhD student Wendy Morales Castro. Today I'm going to present my research work called Identification of Depression Through the Use of Decision Tree. The authors are PhD Rafael Guzman, PhD Jose Ruiz, and finally PhD Teodoro Cordova. Before we start, I would like to talk a little about us. We are proud to represent the University of Guanajuato, located in the heart of Mexico. As shown on this slide, the image on the right shows the iconic main building of the University of Guanajuato, a symbol of excellence and commitment to education. Next, we can also see one of the university's headquarters, where much of our academic work and scientific research is currently carried out. This headquarters is the Department of Multidisciplinary Studies Uriria campus. Well, to start on the next slide, I show the table of contents of the presentation. As the first point, we have the introduction, followed by the state of the art, methodology, experiments, results, conclusions, and finally references. I will start with the introduction. Currently, one of the main causes of death in the 15 to 29 age group is depression. Some data obtained by the World Health Organization indicate that every year 700,000 suicides are registered because of it. But what is depression? Depression is an emotional disorder that causes a feeling of constant sadness and loss of pleasure or interest in performing some activities for long periods of time. This can affect the feelings, thoughts, and behavior of the person. Some statistical data obtained from the Statista portal on how common depression, stress, and anxiety are in some countries show the relevance of treating these mental health issues. These data belong to people surveyed between July 2022 and June 2023 in a range of 18 to 64 years old. In this graph, we can see that Mexico is in 7th or 8th place on the list, with a tie with Spain, where 30% of respondents said they had experienced mental health problems in recent months. The AI has currently stood out in various areas. Undoubtedly, one of the most prominent areas is medical area. AI has the potential to contribute to improving health in societies, but not all countries are betting on it in the same way. Some of the countries that dominate the use of AI across all sectors are the United States, China, and the United Kingdom. That is why, when observing the problems presented in society by depression, it was decided to make use of AI to develop a system that allows us to identify it. Generally speaking of AI, AI is nothing more than providing knowledge to a computer so that it thinks and acts like humans. One of the most important fields within AI is natural language processing. One of the definitions that I like to use to define natural language processing is to define natural language first. Natural language is nothing more than the way we communicate with each other. There are various forms of communication. Two of the most common are written and verbal communication. Now, for a computer to understand our language, a series of techniques must be followed or used. The whole grouping of these techniques is known as natural language processing. For this work, we focus on written natural language processing. Some of the tasks that can be performed with natural language processing are document classification, sentiment analysis, as well as identifying polarity on Twitter, comparing texts, analyzing documents, and identifying mental or health disorders, among many others. This type of tasks have been implemented in various research projects today with data obtained from social networks such as Twitter, Facebook, Instagram, etc., due to the large amount of information that is generated daily in them. In the following figure, we can see a graph of the number of internet users and how many of them use social networks, as can be seen until February of this year. There were more than 5.24 billion users of social networks, which is why the use of this generated information is relevant, because a huge amount of information is generated daily that can be relevant in various areas, including the medical field. When carrying out a review of the state of the art, important points were observed that allow the focus of this work. In the following graph, some of the articles reviewed are shown. 70% of them are focused on languages other than Spanish, and only 30% are focused on the Spanish language. On the right side of the presentation, I show some examples of works found in the state of the art. When carrying out an analysis of various researches, it was observed that some of the works in the Spanish language are based on questionnaires prepared by experts or systems carried out by experts in the area manually. Some methods used by experts for the detection of symptoms usually consist of surveys or questions of a very personal nature, and consequently patients do not agree to submit to this situation or answer incorrectly to these methods, which would affect the veracity of the information. Other works make use of tools made in other languages but using translation. These present some problems that lead to the reduction of the veracity of the results, or the bias produced by the translation of the data. It is important to mention that this task has acquired greater popularity in countries such as the United States, the United Kingdom, and China, but because each language has its specificities, it is important to give sentences the correct treatment to understand their context. This is where the motivation of the need to have a system that helps with the identification of the disease through natural language processing techniques arises. This system will focus on carrying out a pre-training of data, avoiding the use of already established questionnaires, and of which some authors make use, and in turn focus on carrying out the system in Spanish, since very little information is presented on related works. With these data in mind, I continue to talk about the methodology. The general methodology proposed for this work is as follows. What we are looking for is that the system is able to identify tweets automatically, as some examples that can be seen in the table. Each of the tweets will be labeled with its respective legend of depression or non-depression as appropriate. Also, in turn, evaluation metrics will be obtained that will allow us to evaluate the accuracy of our system. The general methodology of the work is shown in this diagram, where we have as input the corpus labeled by experts. The corpus will enter the system, and finally each tweet of the test set will be labeled with its corresponding caption. Speaking specifically of the methodology, the following diagram was developed. As a first point within the methodology, the corpus will be manually tagged. This selection contains 1,000 tweets manually selected by experts and tagged with the legend depression. These were published by 90 different users and extracted from the Kaggle platform, and the second class will be tweets that were previously downloaded by us about another topic. Previously, we made sure that these tweets were not related to the first class. These tweets will be labeled with a caption, "No depression." And in this way, we will have our corpus. Following this, the corpus will enter the pre-processing stage. in order to clean the data and add features that help with the identification of depression. Within the pre-processing, 4 stages will be carried out, which consist of the elimination of stop words. Within this stage, empty words will be removed from the corpus, null characters, punctuation marks, etc. Conversion from upper to lowercase. Tokenization. It consists of grouping each comment into subsets such as unigrams, 1 single term, bigrams, 2 terms, trigrams, 3 terms, etc. In our case, we use unigrams. And finally, the lemmatization. It consists of returning each of the terms existing in the corpus to its base form, that is, as they appear in a dictionary. Once this is done, the next step consists of the construction of the classifier, where the necessary structure is given to the pre-processed corpus and the classification scenarios are formed, the training and the test scenarios. The training will be used with their respective tags and the test without them to validate the methodology. The classification scenarios used were cross-validation using 10 folds and training and test sets using 80% of the data for training and 20% for testing. Once these scenarios have been created, we will enter the depression identification stage, in which 3 machine learning methods will be used, such as random forest, J48, tree decision. These techniques to be implemented will be evaluated within the next stage. Within the result stage, the evaluation of the learning methods used within the previous stage will be made, and for this the precision metric will be used. In turn, the tweets will be labeled with their respective class. On the other hand, we have the obtaining of information gain, which will be obtained based on the corpus with the best results, in order to observe how each experimental configuration to be carried out affects the results of the system. To carry out the methodology, 3 experiments were created. The first of them is generally known as baseline. This experiment is carried out in order to observe how the data behave in a crude way. For this, all the existing words in the corpus were taken into account. That is, there was no elimination of stop words. Only the data was prepared to be read in the processing stage. That is, the conversion from lowercase to uppercase was applied and tokenization was performed. After this, the scenarios of classification, cross-validation, and training and test set were created, after which the processing was carried out with the 3 learning methods mentioned, and results were obtained. For experiment 2, the change was the use of the 4 levels of preprocessing to verify the change in execution time, vocabulary size, and system performance. For experiment 3, we base ourselves on the results obtained by the 2 previous experiments, this to verify which of the experiments gives us better results, and use the labeled corpus obtained at the output of the best experiment to be able to calculate the gain of information, this to have the attributes with greater weighting that help the division of the classes. This information was used to carry out the new experiment, in which the 4 stages of preprocessing and the same following stages of the methodology were used in the same way. The creation of these experiments was due to the relevance of the topic. As they are medical issues, greater care must be taken with the use of information and the analysis of it, in order to have a more precise system in terms of the identification of the disease. As results of experiment 1, we have that the random forest learning method was the one that obtained the best results. In the case of this experiment, there was a vocabulary of 35,675 words, of which 5,795 were different. We also show the execution time of each of the learning methods used within each of the classification scenarios. For experiment 2, the random forest algorithm was also the one that obtained the best results. The vocabulary, the different words, and the execution times in some algorithms were reduced. For experiment 3, the following results were obtaining a greater range of precision compared to the previous experiments, greatly reducing vocabulary and execution times. As can be seen in the graph, In each experiment, the size of the vocabulary and different words progressively decreased due to the types of preprocessing applied. These preprocessing procedures impacted the results obtained, both in terms of accuracy and in the execution time of each experiment. Taking into account the precision shown in the results tables, the gradual increase was observed throughout the experiments, having an increase of 5.8% between the first experiment and the last experiment, based on the best result obtained from each experiment, and a decrease of 62 seconds and 38 milliseconds. In terms of the execution time of the result with better precision of Experiment 1, against the best accuracy result obtained from Experiment 3. With this data, it can be deduced that performing and varying the type of data processing within the preprocessing can help to optimize the classification results and the execution time. In turn, experimenting with various classification algorithms can help discriminate which ones work better than others in terms of identifying depression in tweets. This is relevant so that experts in the area, such as psychologists or psychiatrists, can have tools that help with the identification of the disease and ensure that a correct medical diagnosis is made and its respective medical treatment is followed. In the next slide, I show the references used for this work. And finally, I introduce you to our team. The PhD in Artificial Intelligence, Rafael Guzman. PhD, Jose Ruiz. PhD, Teodoro Cordova, and I PhD student in Engineering Sciences, Wendy Morales. I appreciate your attention. Thank you. I am waiting for doubts and comments.